Hello and welcome to Meetings in Math. You are here for 4.1, Writing and Graphing Inequalities. And how can I use a number line to represent solutions of an inequality? This is the very beginning of inequalities and how do they work and how can we represent them. You're going to need your Jaguar dots, a pen or pencil. Highlighters might be useful today. You'll need to be on 4.1, page 2 in the chapter 4. You will need your positivity, your dedication, and your determination. And let's go ahead and get started. So we're going to start by looking at 3 different ways that we are looking at inequalities in a real life situation. The first one is you have less than $50 in your piggy bank. So let's begin by sketching out what it looks like on a number line. So we know that we have something revolving around $50. So we use an open circle to represent that. Now the question is the $50 included or do we have more or do we have less? Well, we can see by the word right here, less, that we have to go less than that. Now the question is $50 included in that amount? Well, if we wanted to include $50, we would have to use things like no more than or no less than, things like that. So no, we don't include $50 in this. So we use an open circle, and that's how we write it. So now let's go ahead and write the inequality that would be used because it actually told us to write the variable inequality. So let's use M to represent money and let's compare M to 50. So what would you say about the amount of money? Would you say you have less money or more money? Well, you would say you have less money because that's what this says. So you would use the less than inequality to represent that. So for the next 2, we're not going to make a number line, we're just going to write the inequalities. You have no more than 15 video games. So we're going ahead and we need to define our variables. Let's let V equal our video games, and we're going to compare V to 15. No more than means that we have to compare to our 15. And when I say no more than, I know that I'm including 15 in that answer because when I say things like no more than and no less than, I know that 15 is a changing spot. But when I say I have no more than, if I had 16 videos, that would mean I have more than. And this is saying I can't have any more than. So I know I have less than 15 because that would be things like 14 or 10. But I could have exactly 15 as well because it says no more than 15. So 15 would still be no more than 15. On the last one, when you went trick-or-treating, you got more than 100 pieces of candy. So we're going to let C equal our candy, and we're going to compare how much candy we got to 100 pieces. And it says more than. Now it doesn't say I got exactly. It doesn't say no more than or no less than. It says I got more than. So I know that I have more than 100 pieces. So more than would be the greater than symbol. So refer back to the graphic organizer that we made. If this doesn't make a lot of sense, that graphic organizer should help you a great deal. Remember, it looked like this. That should be helpful if these weren't making a lot of sense. So now let's look at the phrase, I have at least $20, and the representation X is greater than or equal to $20. At least means at $20, something happened. When I say I had at least $20, it means that I have $20 at a minimum, and then I could have more. When I say you have at least $20, that means you could have $21. That also means you could have 22 or 25. 15 is not at least 20. So things this direction don't work, but things this direction do. So at least $25 would look like that. That is why X is greater than or equal to 20, because our numbers are larger than 20 or equal to. Since I said equal to, I have to have a closed circle. So I have at least $20 means I need at a minimum $20, but I can have more. So now it's your turn. So let's look at this right here. I'm not going to say out loud what it is. I want you to interpret what this says. So you may need to write it out in words. So like this one right here, written in words is X is greater than or equal to 20. What does this say in words mathematically? And then what is a phrase like this that it could represent? Go ahead and pause it and then come back and let's see how your phrase compares to my phrase. So when I did this, I wrote my phrase mathematically, x is less than or equal to 30, which I knew looked like this. So I know that this means I have no more than $30. I kept up with the money phrases because that's what made sense to me. I could also say I have no more than 30 oranges. I don't know why I would want 30 oranges, but I could say that. I have no more than $30. I could have $25, I could have $29.99, but I cannot have anything more than $30. So a solution to an inequality is any variable for the variable that makes the inequality a true statement. So for example, 25 would make this a true statement. So would 27, but even negative 30 would make this a true statement. Negative 10 would make it a true statement. So would 10. Inequalities have an infinite number of solutions. This goes infinitely this direction. Negative numbers are going to make this true. This one right here goes infinitely in the positive direction. All of those numbers would make it true. So again, a solution to an inequality is any variable for the variable that makes the inequality a true statement. Inequalities have an infinite number of solutions. So we're going to explore that idea here in A and B. These are possible solutions for x that might make this true. If it makes it true, it is a solution. If it makes it false, it is not a solution. If it is a solution, we're going to circle it. If it is not a solution, we are going to cross it out. So we're going to use evaluate to figure out whether or not it is a solution. So if we evaluate, is 2 plus 7 greater than 10? Well, that would be 9. Is 9 greater than 10? This is false. So this is not a solution. Oh, this was negative 2. It's even worse than that. Negative 2 plus 7 is a 5. It still doesn't work. It was just worse. So on the next one, is 0 plus 7 greater than 10? Is 7 greater than 10? That is false. So this is not a solution. On this one, is 3 plus 7 greater than 10? Is 10 greater than 10? It is not. It is only equal to. So this is false. So 3 is not a solution. Is 5 plus 7 greater than 10? 5 plus 7 is 12. Is 12 greater than 10? It is. So 5 is a solution. So the only one that worked here is 5. That doesn't mean that there's not other solutions. It was just out of the choices we were given, 5 is the only one that works. So this one is negative 3 times negative 2 is less than 9. Negative 3 times negative 2, so when they're right next to each other, that means you are multiplying. So is 6 less than 9? That's true. So this is a solution for this one. Negative 3 times 0 is less than 9. Is 0 less than 9? It is. So this is a solution. I want you guys to do these two. Come on back after you've done them. Okay, so you ended up with negative 3 times 3 is negative 9. Negative 9 is less than negative 9. That's true. So this is also a solution. And on this one, negative 3 times 5 is negative 15. Negative 15 is less than 9. That is also true. So this is a solution. So in this case, they all happen to work. So it just depends on what your inequality is as to whether or not they're going to work. And yes, you do need to try them to figure that out. And I don't want you guessing. I want you figuring them out through evaluation. So that is writing and graphing inequalities. There's a lot of work involved on them, but if you take your time to slowly, methodically work through them, you should understand them. What I want you to do for tonight is I want you to do the number lines for V is less than or equal to 15 and C is greater than 100. And remember, you don't have to start your number lines at 0. See how I didn't start them at 0 right there? Thank you so much for joining us today. And remember, be kind to each other because we all could use some extra kindness in our lives. Bye for now.